Um, Greetings, everyone. Um, Thanks for attending this Keysight Connect event. My name is Tudor, and for the next 30 minutes or so, I'm going to talk about open source, a subject that's very dear to my heart. At the end of the talk, I hope that I will have convinced you of the benefits of using open source, and also why it's important to contribute the code developed inside your company back to the open source community. So let me turn in the slide. These are the main points we're going to touch on for the rest of the presentation. We're going to start first by defining what is open source and what are some common types of licenses we could confront ourselves with. Then we're going to try to understand what types of benefits open source could bring to our project. We're going to present a case study about how we use open source inside our company and how we are contributing back. And when approaching the finish line, we're going to try and draw some lessons from our current experience. But first, let me share a bit of background information on myself and how I got started. So I've been working in the industry for about 10 years, and I first learned about open source back when I was a student at the Polytechnic University in Bucharest. Back then, I participated at an internship in which I had to develop some plugins for Redmine. If you've never heard about Redmine, you can think of it as an issue tracking system, kind of like Jira. While writing these plugins, I was fascinated by this new way of developing things. I enjoyed how easy it was for me to extend the functionality of existing software and by having all of the code available in front of me. And how quickly it was for me to be able to hack something and get feedback from other users. When I started to work for Ixia back in the days, the product that I was working on used a customized version of the Linux kernel. Most of you probably know that Linux is the largest and most successful open source project in existence. There are about 3 billion Android devices, I think, which run kernel based on Linux. And also much of the internet's backbone, when you think of it, is composed of servers running Linux. For this particular project, we had to customize the TCP/IP stack of Linux in order to meet some very stringent performance requirements. And naturally, Linux kernel development is not an easy task, right? You kind of have to know what you're doing. But my colleagues managed to obtain some pretty impressive results. However, doing so, we diverged quite a bit from the mainline version. Now, when newer versions of Linux are released, they normally come out with bug fixes or support for new types of hardware. So you have a lot of reasons to want to have the latest version, but unfortunately, when we tried to upgrade to a newer kernel, we had a pretty rough time. It was a fairly big effort, as we found out. And that's when I learned of a potential problem with open source. What could happen if you move too much away from the version that's considered to be the official one? But first, let's take a short detour and prepare the ground for the further discussion by uh, talking a bit about open source. Please bear with me, even if some of these notions might seem trivial for you. To start this discussion, I picked the definition from Red Hat, which I found to be the most concise and to kind of capture the essentials. When talking about open source, we typically refer to code that is public, that the user could see, modify, and distribute with everybody. Up to this point, it should be pretty straightforward. We'll see that things will start to complicate a bit the moment we're talking about the distribution part. We'll see this later while talking about licenses. Open source is also software developed in a collaborative way, meaning multiple people could share their contribution, but it's also distributed. These people could be working from different locations, countries, or continents. It is said that open source projects usually have a bigger lifespan compared to projects developed by a single company. And this is due to the collaborative way of development. If, for example, a company stops using an open source component, there are still big chances that other companies will still use it, which kind of ensures a bigger lifespan. Any discussion about open source would probably be incomplete without briefly mentioning the various types of licenses that surround it. I won't get into a lot of details on licensing, it's not the main scope of the presentation, and a lawyer would probably be better suited to discuss the various intricacies. So what I'm going to describe is mostly the result of my understanding on the subject. The term free software precedes that of open source, as we can see in the following table. The term was invented, if I'm not mistaken, by Richard Stallman, who founded the GNU project in the 1980s. The distinction between free software and open source is mostly a philosophical one. In practice, they kind of describe the same type of software. Therefore, going forward, we're not really going to make a distinction between free software and open source. We're going to use open source as a generic term. We could say that free software is more concerned with the rights of the user regarding what he can do with the code. In the English language, as opposed to Romanian, for example, we don't really have separate words to describe free in terms of liberties and free in terms of price. Having access to the code doesn't mean that you can charge money for modifying it or distributing it. That's why people, when discussing about free software, they often say the expression free as in speech, not free as in beer. On the GNU site, you can find an article called The Four Freedoms of Software, which I recommend reading. This article talks about the four freedoms that software called free should have from the perspective of the user. We're just going to mention them really quick, as they could help us understand the philosophy behind the free software. So the number zero freedom is being able to run a program. The next one allows us to study the program and modify it as we see fit. The last two talk about being able to distribute the program to other people and distributing copies of the modified program to other people. If you study the GPL v2 license a bit, you will see many of these ideas put into practice. And besides what we've talked about, it's also worth mentioning about public domain. Public domain is basically code that is outside of the copyright area. You could probably classify software licenses into two big categories. Some of them are permissive, like the Apache, the BSD, or MIT license. And there are also some licenses which impose some more restrictions on us. We usually call them copyleft licenses, and they normally originate from the Free Software Foundation. Copyleft licenses try to prevent the inclusion of code under such a license into a proprietary product in which the user's access to the code would be prevented. The most conclusive example is the GPL license, but there are also subvariants such as LGPL, which allow you basically to link with a library under the incidence of this license without necessarily forcing you to expose the code under the same license. Therefore, kind of allowing you to make your code proprietary under certain conditions. Permissive licenses such as Apache, BSD, or MIT don't normally don't normally impose a lot of restrictions, except the need to mention the author, for example. I just wanted to get an idea about how much we rely on open source inside our company. And the answer is a lot, actually. I've identified at least 200 third-party packages, most of them being open source. They're used across many of our existing products. So we could safely say that we depend quite a lot on open source. Why did I bring this up? Well, chances are that you're in the same boat as we are. A study which was conducted in the UK last year has shown that 9 out of 10 companies use open source in order to accelerate time to market. Also, studies consistently show that open source is perceived to be more secure than proprietary alternatives. So from a business perspective, it's really critical for us to be able to work with this type of third-party software and be acquainted with the development model behind it. Once you use open source inside your product, it's very frequent that you experience a life cycle similar to what I will describe here. First, let's say you take version X and adapt it in order to work fine with your product. Well, most of the times this means that you have to modify your product to call the API exposed by this package. But often it also means bug fixing, right? Things don't always go smooth from the beginning, and during QA testing cycles, we often find issues which need fixing. After a while, we realize that we have to perform the upgrade to version X plus 1 this time. And very often we are required to reapply all the patches from the previous version, which might make this upgrade process to be more difficult than it should. The integration work should not be neglected either. If you are behind the mainline version with just a few releases, the moment we're going to upgrade the component, well, we need to spend some extra effort because it's highly possible that the API exposed by the package to have changed significantly. And so we need to perform additional changes in our program. When we'll find ourselves in the need to perform a second upgrade to version X plus 2, we're basically going to start over again. So we could see that upgrading could be long and painful sometimes. However, there are multiple reasons for wanting to upgrade a component to the next version. First of all, it's considered as a good practice. We always assume that newer versions are usually more stable. Sometimes we find that the previous version has gained some vulnerabilities appeared in time. This is normal. As time goes by, we frequently uncover some security flaws. With time, a lot of bugs are identified and solved. A newer version could also bring performance improvements or improvements in terms of functionality. For example, we could get driver support for some new type of network adapter or um, which our customers would want to use. The patches which we have to reapply the moment when we perform the upgrade are most often a non-negligible work quantity. And it's often time you would rather spend on adding new features to your product. So it can potentially be long and tedious work, but it doesn't have to. We'll see in the next part of the presentation an approach I will advocate for, which I believe could make your life easier. The first case study we'll talk about is the Linux kernel, which we use in a particular legacy product. I briefly talked about it in the introduction. The last time we performed an upgrade was a very long time ago. So we're talking about a few hundreds of patches that have accumulated um, over the time, and uh, we, and we're not necessarily talking about trivial patches which change configuration options. Some of them even change complicated aspects of the TCP/IP stack. The version of the kernel we're using is beginning to show its age. The last time I checked, the latest stable release was 5.17, I think, which appeared this month. As developers, we often want to work with bleeding edge technology, right? But unfortunately, in our case, we don't have access to new and cool features that we can see in newer kernels like eBPF or XDP. The next case study I'm going to talk about is DPDK, which stands for Data Plane Development Kit. It's a set of libraries which could help you achieve really fast packet processing in user space. Frequently, the TCP/IP stack of your operating system could become a bottleneck when you need to process network packets at a really high rate. Here comes DPDK to the rescue. With the help of it, we could build virtual networking functions which could scale much better. So we started using it for our product a few years back, and it appears that at least 6 other teams inside our company are using it for their own projects. We're not necessarily sharing the same code repository with them. We always want to keep up with the requirements of our customers, and with time, we often found ourselves in the need to upgrade the DPDK to a newer version. Now, we've discussed about the major reasons for wanting to have the latest version of a package, and they apply to us as well. But I would say that the dominating factor for us is definitely the support you get with the upgrade for newer types of network adapters. We could see that we started with the 17 version, and we had a relatively small number of patches at the beginning, but this number started to increase with time as we added support for new network cards and drivers. We frequently found bugs and had to fix them by changing the code or even by customizing various aspects of the drivers. We've recently completed the fourth iteration of an upgrade lifecycle, and it's not always fun. I think it took us at most several weeks in order to complete an upgrade. and probably a few more until we were pretty sure the product was relatively bug-free. There are some patches which you end up carrying from the previous release, and then you kind of begin to pile new patches from the current one on top of them. And you basically end up with the giant thing on the right. We can see where this is going and the fact that the upgrade operation could become more difficult. So starting from version 20, we saw that the list of patches was growing and was kind of becoming increasingly difficult to manage. So it took an important decision at this point. We started looking into how we could upstream the patches. Perhaps if we start discussions with the open source community and maybe just get some of those patches accepted, we will make our job easier in the future. Now, let's see why we would care about upstreaming. Well, in some cases, making the code available is kind of a necessity. For example, if we use a program which is under a GPL license, and this program is important for our business needs, but um, let's say it doesn't exactly do what we want, and we have to modify the code a bit. Well, in this case, the GPL license requires us to make our code changes available to the users of our product. So if we have to make our patches public, why not go one additional step and try to upstream them? It's also in the spirit of helping the community. We clearly benefit a lot from open source and software developed by other people. Why not share back some of our contributions? Think of it this way. When somebody develops a program, he will check that the program is working correctly and maybe also write some unit tests. But there's a very high chance that he might have overlooked a scenario, like, for example, running the same program with a different set of input parameters or maybe running it on a different Linux distribution. So inevitably, bugs will appear, right? If we contribute back with the fixes we find, it's basically a small token of appreciation for the developer. A side effect to this would be helping other teams inside your company, which might use the same software package. In our case, we've seen that DPDK was used by at least 6 other teams in the company. So we don't necessarily share the same code repository, but let's say we find a bug, fix it, and then manage to contribute the patches back to the community. The moment they will upgrade their own version, it's going to contain our fixes. So we could see that we are helping them without even knowing that they exist, right? By following this upstreaming process. Also, it could greatly reduce the effort on our part required to upgrade between versions. If the number of patches gets out of hand at a certain point, it might be almost impossible for us to migrate to newer versions. So we'll have to stick with an old one and maybe with a lot of bugs, which is the case with the Linux kernel used in this legacy product. Maybe the most important aspect is peer review. Typically, when we perform code review inside the company, there are maybe one or two people glancing over the code. This is probably the most common case, right? When you try to contribute a patch back to the open source community, you instantly gain access to people which have a very good understanding and expertise on the subject, and who can offer you valuable feedback or maybe even suggest you with an alternative implementation. Think of it this way. The quality of an academic paper is also given by the quality and amount of peer review it has undergone. This also applies to software. Therefore, it is my belief that it's a good way to improve the quality of your code. Okay, so we've mentioned some positive aspects of contributing. Let's see what the drawbacks could be, or maybe it's not really the right term. Well, first, it's a process that can take a lot of time. For each patch that you plan to upstream, you must basically convince the community about why it's really needed. You kind of need to justify yourself for each code change that you are doing, and basically demonstrate to other people that this is really the best way and you have no other better alternatives. So this frequently means that you must do additional research or that you need to explain very clearly to other people the way in which they can reproduce the same bug. So in our case, for one particular patch, Just to give you an example, we had to provide an automation script to the maintainers. This was done to help them observe the same incorrect behavior as we did. The maintainers are usually busy people. They frequently have other tasks, so it could take a while until they finally respond. For one patch, I had to wait about 2.5 months, I think, until it was finally accepted. There were a lot of back and forth discussions during this time, so it's a process that can be painfully slow at certain times. Unfortunately, there will always be patches which will never be accepted upstream, no matter how hard you work towards this objective. And that's normal. The maintainer has full liberty of refusing certain patches because um, they might clash with the way he sees their program evolving in the future, or maybe they don't fit well with the overall architecture he has in mind. There might also be the concern of not helping the competition indirectly by sharing some of the code developed inside the company. And it's often a valid concern if you think about it. And there is no easy way to answer this. You must discuss with your colleagues from the legal department to understand if there are valid reasons to worry. So if you want to start upstreaming, the first thing that you want to do is really identify which subset of patches is it worth to share with the community. This will help you focus on what's important. The next very important step is to be sure that you don't have any problems from a legal standpoint. In most companies, when you are hired, you frequently must fill in some papers. And often they say something like every code you develop during work hours or using your work laptop maybe becomes the property of your employer. So to get the code out of your company to share it with the community, you would want to check with your manager and legal department if they are okay with that. Once you get this out of the way, then you can start discussions with the community. Each project will typically have at least one maintainer. A maintainer is basically a person who will handle all aspects related to code review, bug fixes, and overall architecture of the component. So to manage, to upstream your patches, you need to get in touch with this person. In cases in which there is an intense activity around the project, meaning there are a lot of people who frequently contribute with patches, um, typically this communication will be formalized. And to give you an example, the project could be hosted on a publicly accessible Git server. GitHub is very popular for that. Then we would normally create a fork of the entire repository, include our code changes, and then we need to notify the maintainer through a pull request. Websites like GitHub or Bitbucket have been making this process to be really smooth. The maintainer can then accept your patch or maybe come up with other suggestions and respond to the pull request with a comment. This is one frequent way of contributing, but there are also projects which are more traditional, if I could say. Some of those projects started even before Git began to be widely used as a versioning tool. In these projects, we typically use an email list to send patches. I think Git appeared about 15 years ago, but email has been used in a form or another starting from, I think, the 1970s. So it's one of the first tools which could facilitate large-scale collaboration. And the best example we have here of a project which uses an email list is the Linux kernel. Another one is the DPDK, which draws a lot of inspiration from the first one. As you will see, it tries to mimic a lot of the development process from Linux. And important to mention is the fact that if the project is mature, it's very likely that the way of contributing will be well documented. DPDK has a very good documentation. The first thing you want to do if you plan on contributing to it is read the contribution guide, which is very comprehensive. They start by describing the development process, what types of licenses you should use for new code. Uh, to give you an example, they're using BSD for user space code and GPL v2 for their kernel modules. And after this, you should read the coding style guide. which is also very comprehensive. I think I counted about 25 pages of information, and they really go in depth here, starting from how you should indent your code, the order you should use when including header files, even where you should place the asterisk when you are declaring a pointer variable. And the coding style guide is heavily inspired from the one used in the Linux kernel. You might find a lot of similarities. Then we basically need to identify the maintainers with whom we need to interact with and which tree we should rebase our patches against. We can see that there are a large number of trees. As we can see here, the main line is the main Git tree. So that's where we want our patches to finally arrive. Another important tree is NextNet, which basically contains new features that will make it into mainline soon. And also, NIC vendors will frequently have separate locations in which their features are going to be developed. For example, Broadcom has a separate tree. Intel also has one. So let's say we want to submit a patch for the XGB driver from Intel, um, from Intel's 10 gigabit cards. We will investigate this file for the XGB section, and then with capital M, we can see the maintainers who handle code review for this tree. You will need to CC them while submitting the patch to the mailing list. And with capital T here, we can see the Linux tree we should use to rebase our patches. In this case, it's called DPDK NextNet Intel. Now we can finally prepare our patch. We could use the Git format tool patch for this job. And to check that we don't have any coding style issues, we need to run a script called checkpatch, which might be familiar to you if you've sent a kernel patch previously. We need to keep in mind to describe the problem we're trying to solve in easy terms for other people. Our commit message should include information about why this patch is needed, what does it implement, and how does it achieve that. Maybe if you're using a non-trivial algorithm to solve a problem, you should probably add some links in the patch for some further documentation. Okay, so now we're going to send our patch to dev@dpdk.org and also register to Patchwork, a web tool they use for managing patches. And normally it could take a while until somebody reviews our patch. And if you submit it when the release is approaching and manage to miss the merge window, it can take even a bit longer. But there are exceptions to that. And one exception is if your patch contains a bug fix, it's going to be treated with the highest priority and you will get feedback soon. Once you have your code in DPDK, however, things are not over, right? If you develop a new driver and publish it, you are basically a maintainer now, and you should be available to on the mailing list in order to answer to various questions people ask, or maybe to investigate bug reports by people who are now using the code you've written. And there's also a separate mailing list called stable@dpdk.org. Some branches of DPDK have long-time support. Normally those ending with 11, like 20.11 or 21.11. Those are long-time support branches. This basically means that they'll have a dedicated maintainer who will frequently backport fixes from mainline. You might be asked by this maintainer to rebase your patch, which was accepted into mainline, into an older and stable branch. Okay, so let's see our current status. Up to this point, we have 8 patches that have been accepted upstream. For one of them, we had to wait, I think, 2.5 months until it was finally accepted. So you really must prepare yourself with a lot of patience during this time. And you need to communicate frequently with the maintainers and provide answers to all of their concerns. One advice I have for you is to increase chances of, in order to increase chances of successfully having your patch accepted, is try and make your code a bit more generic and reduce customization as much as possible. And here I can give you two examples regarding some of our own patches which were accepted. So for the first one, we needed a thread to be scheduled more often on the CPU. So instead of hard coding the new value, we offered we offered an option to the user so that he could configure the desired granularity. In our case, we wanted to improve performance and didn't really care that much if we used some more CPU. But for other users, the CPU usage might be more important. So making the option configurable could greatly improve your chances of having your patch accepted. And a second patch, which I could provide as an example, is related to the AF packet driver. The problem we had is that in the Linux kernel, VLAN stripping is implicitly enabled for sockets of type AF packet. And this basically means that if you use raw socket um, and the packet we wanted to receive has a VLAN tag, this tag will be extracted and usually be placed in some metadata headers in the socket buffer structure. So this could be a problem if your code inspects the packet and maybe looks for a certain signature at a given byte offset. What we did was to basically add the VLAN offload capability to the driver, and so making this option configurable by the user. So when the user disables VLAN stripping, the driver will see this, and in case that our VLAN tag is extracted, it's going to be reinserted in the packet. And of course, we had to do some decent amount of testing and basically prove that there were no significant performance degradations. This was the main concern of the maintainers. It's also the reason why it took us a bit longer to have this patch finally merged into mainline. Unit tests or regression tests could also help you out. They are your best friends. When you take a newer release and reapply all the patches and solve the eventual integration problems, you normally want to be sure that there are no collaterals, right? Maybe not necessarily due to your patches, maybe due to some changes that were done upstream. We want to have some faith in the fact that we don't introduce new problems. And that's why it's of great importance to have some automated testing in place. For us, they really helped reduce in reducing a lot of from the upgrade time from several weeks to less than a week um, for the last DPDK release. If you know you've got an open source component and uh, find yourself in the need to upgrade very often, try not to let the number of patches get out of hand. Otherwise, it's going to be some titanic amount of work navigating from one version to the other, and you're just going to spend a lot of time porting patches. There is also the real risk of so many patches accumulating such that the effort would be too much, like it was the case for our Linux kernel. This way, we could get stuck with an old version, which with time will have accumulated various vulnerabilities and bugs, and will basically lose access to new functionality to new functionalities which could be present in the latest version of the software. Okay, we're approaching the end of the presentation. I just want to highlight some tools which I think helped me in this journey. I previously mentioned we had to use an email list to send patches. The usual email clients like Outlook aren't really well suited for this task. To give you an example, some of them, if they encounter an odd character in your email, they might encode the whole email in a base64 format. And Outlook also has a default behavior, which is annoying for mailing lists. It implicitly does stop posting. This means that the last replies from a thread are placed at the top, which might make it more difficult for other people to follow the discussion. If you use stop posting, it's um, very likely that somebody from the mailing list will notice this and warn you. So in the right part of the slide, we can see an example about the reasons why top posting is generally frowned upon in mailing lists. So in some cases, if you don't follow the strict conventions of an email list, people will not even look at your patch, even if otherwise it may be a useful contribution. It's generally recommended to use a button posting style, or even better, the interleaved or inline posting. This means that we will extract from the previous email only the paragraphs to which we want to respond and place the text of our replies below them. Of course, the best tool to send patches is Git send email, but we could also use email clients like Math or Thunderbird. They're pretty straightforward to configure and use, and I've put a link in the bottom part of this slide. It's from the Linux kernel documentation, from where you can find some useful resources to help you configure your email clients. Okay, let's see a bit what follows next. We would like to continue upstreaming patches. We did our last upgrade recently to the 21 version, and we just recently found a bug when setting the MTU for a particular driver. We fixed it locally, and we're going to start discussions about this patch very soon. We also have in mind to publish other work developed by us in the form of additional features. It's mainly about exposing some new offload capabilities for a certain Intel driver. However, it's likely going to be much more complicated to get this work accepted because it also touches some code areas which are common across all the drivers in DPDK. But I think it would be nice if we succeed. It could probably align our goals with the community. Um, we're thinking if it makes sense to apply the same approach to other projects as well. Good candidates would probably be packages which are upgraded often and with a certain degree of customization. And maybe it's a good idea to start with an upstream first mindset, meaning that all the patches we develop will be written with the goal of having them accepted into mainline. So in conclusion, I believe that upstreaming could be a useful tool which could be leveraged to reduce your workload and complexity in these cases in which you need to upgrade an open source component very often. And we've discussed about the need of upgrading either due to having access to new features or just to have fixes for various bugs or vulnerabilities. This was my presentation. I hope you enjoyed it, and hopefully you are a bit more curious now about open source. Um, I think that at least for students and young engineers, the experience you gain through collaborating inside an open source project is very useful. It's a style of developing software which I believe will help you become a better engineer. So from my point of view, the best way of learning how to code is take an open source project, play with it, modify the code, and then just ask for feedback. So finally, I wanted to offer you some links which I found useful about open source in general and as well as about DPDK. Um, yeah, thanks a lot for your attention. So if you have any questions, I'd be happy to hear them.